Right, page 2. Before we go on, just because I know some of you will want to know the exact answers to question 1, here they are. 8 pi plus 45 is 70.13, 210 plus 32 pi is 310.53, and 35 sine 4 wasn't 34 wasn't 19.57, it's 2 decimal places. Right, let's move on. You want the perimeter and area of a sector. Now, your formulas for the arc length and sector area are thus. Arc length is a fraction of a whole circle, the circumference of a whole circle, so it's pi d times the angle over 360. Sector area is a fraction of the area out of the fraction of a whole circle, so it's pi r squared times fraction over 360. Simple enough. So you've got 48 3/60ths of a circle here. The one thing you have to be careful of with perimeter is this arc length is just the curve length. If you ask for the perimeter, it's the arc length plus the two straight lines. So if we start with perimeter, it's going to equal this curved bit, which is pi d times x over 360 plus the two radii. So diameter, well, the radius is 10, so the diameter is 20, so this is going to be 20 pi times the angle 48, so 48 3/60ths of the whole circumference, and the two radii are both 10, so double the radius is 20. I hope that makes sense and I haven't confused you with all the formula here. Basically, we're looking for the fraction of the whole circle that gives us the arc length, 48 3/60ths plus 10 plus 10. So, got a calculator this time. We're going to type in 20 pi times 48 over 360. What's that? Plus 20, 28.8 GP. For the area, we are doing this 48 3/60ths of the whole area, so the area is going to be equal to pi r squared times x over 360. I'm running up from again, which is pi times 10 squared times 48 over 360. It's 100 pi times 48 over 360. Let's pop that in the calculator. 100 pi times 48 over 360, and the answer we get is 41.89. Did you see that? No, it's off screen. Super. Right. Next one's quite tricky. How do you find the area of this shaded segment? Well, given that we've been doing area of triangles and area of sectors, that's bits of circles, that's basically how we do it. We want this shaded area, which is equal to the sector area. So the shaded bit, if we call that A, is equal to the whole sector area minus the little triangle area. Yeah? So if we can work out the sector area, and we can work out the triangle area, our job is done. Let's start with the sector area. Exactly the same as in the previous question. It's the fraction of 360 of pi r squared, so it's 140 3/60ths of pi r squared. Yeah? R is 10, that's 140 3/60ths of that, so we do 140 over 360 times pi times 10 squared is 100 pi. Sorry, it's off screen again, isn't it? And we get 122.173. I'm giving an answer to 3 dp here because the final answer needs to be 2 dp. And generally, if you're working to a final, whatever the final accuracy that you're working to, your calculations should be more accurate than that. So maybe we'll throw the next one just for good luck. There's sector area, answer 3.0. And then the triangle area, we use the half AB sine C rule because we know the two angles and the two sides of the angle between them. But you're saying, wait, we only know one side. Aha, it's a circle, therefore each radius is the same length. So if that's 10, this is also 10. Now we have two sides and the angle between them, so we can work it out from the half AB sine C. It's a half of 10 times 10 times sine 140. Half of 10 times 10 is a half of 100, so it's going to be 50 sine 140. So let's type that in. And we get 32.1394. Now I just subtract that from the original value, so I do 122.1730. I know this quicker.